All right, welcome back. Now, as you may have noticed, the way I approached the Gaussian elimination method in the previous example, there was a way I did it, an order to which I did it in to solve it, to get into that row echelon form. So here's what we would call the order of operations for row operations. So the order of row operations, right? You've heard of order of operations when it comes to adding, subtracting, multiplication, division, exponents, parentheses, right? So there's also an order of operations when you're dealing with elementary row operations in transforming a matrix into either row echelon form or reduced row echelon form. So these are the order of row operations. So it's very straightforward and simple. When you start with column 1 and you obtain a leading 1 in row 1. Then once you have that, then you use that row to obtain zeros in all of the rows below that leading 1. So in the same column as that leading 1, right? Then you move to column 2 and you obtain a leading 1 in row 2 of column 2. And then what you do is you use the elementary row operations to obtain zeros in all of the entries that are below it, right, in the same column. And you do this, you continue to do this in like fashion until you get to the last column, column N, and you obtain a leading 1 in row N, and well, actually at that point you don't need, so that's a mistake, you don't need to obtain any more zeros because there's nothing left, it's the last row, okay? So if you use this order of row operations, then at the end, when you get to the bottom column, you will have the matrix in row echelon form. And that's it. So let's do some more examples.